only 2 people from second period even tried number 11, and none of them got it right. So it is what it is. And I don't know how to fix that. I just don't know how to fix that. I don't. I taught this with tables. Your input is going to be things between -1 and 2. Your output, no matter what you do, is -6. You are supposed to know. You're supposed to know that's y equals -6. It's a horizontal line. You have been expected to know that since you were in 7th grade. What's the problem? I don't understand the problem. Fix it. So I've got 2 points on my line, -1, -6. Should be about right here. And it is solid because these are in, look at that inequality symbol. So -1, -6 would be right here. And then I've got this 0.2, -6, and look at that symbolism. That's an open hole. So the right 2, fall 6, open hole. And then I connect the dots, kids. It's not a hard skill. It's not rocket science. You're actually in what's called elementary or basic algebra. You're not in an advanced math class. I need to be nice. Second one's this guy. It takes things between 2 and 4. Won't actually accept 2, or sorry, it accepts them both with symbolism. If you plug in a 2, 4 minus 2 is 2. If you plug in a 4, 4 minus 4 is 0. So I have the 0.22, solid. I have the 0.40, also solid. And there's that piece. And the last piece is 3. I literally made these as easy as I could make them. I didn't put a quadratic, a parabola. I didn't put absolute value on there. I made them line segments. It don't get any easier than line segments. This thing says x can be 4 or more, and it actually can't be 4, but it could be 5, 6, 7, ... And all it's going to spit back is a 3. Doesn't matter what you throw at this thing. It just keeps spitting back a 3. So 4, 3 exists with an open hole. And the rest of them are all closed, and they just continue on forever. That's the practice graph. 12, I made it multiple choice. I don't get the problem. I don't. You haven't memorized your mother functions. There's x squared, which is this. There's another mother function. It's y equals a constant, which is the horizontal line. And then there's another mother function, which is y equals x. And this one happens to be a transformation of it. So I'm thinking mx plus b. That's what you need. You need those 3 things. And again, I made it multiple choice. Let's just work on some things here. That's a solid dot there. They didn't put an open dot, so it's got to be solid. And this piece of the graph is drawn when x is less than or equal to 0. Look at the domain. Use that as a hint as to what the right choice is. Notice these open holes here and here. That's a value between 0 and 2. With x stuck in the middle. There's no equality symbols on that domain. And the last one's over here at 2. And x is moving right. Right is more, always has been. X is greater than or equal to 2 because we have the closed dot there. If there's not an open circle, it's understood to be closed. This is literally the mom function x to the second because x to the second looks like this. It contains 0, 0, and 1, 1. That's mom. She goes that way. This has a y value of what? 5? It's literally 5. And this one you have to kind of extend and think about mx plus b. It has a slope of up 1 over 2, so you're thinking y equals 1/2 x. And it crosses at 0, plus 0. So you just write the half x, you don't write the plus 0. There's 12. This one, there were 2 individuals in all of second period who got 13 right. That's it, 2. Can't tell me if something's arithmetic or not. You add or subtract the same number. It's all you do. What's up with this one? Looks like we're losing 6, and then we lose 3. So no, it's not arithmetic. 9 to negative 10, we're losing 19. By God, we're losing 19 again. And if you cannot figure that out, you go to your calculator, which you had, and you do like negative 29 minus 10. Oh, it should have been negative 10, shouldn't it? Negative 29 minus a negative 10. There's the difference of 19. Negative 10 minus 9. There's the difference of negative 19. You had access to a calculator. So yes, ruh-roh, there's fractions. I don't know, type in a half minus a quarter. See what the difference is. It's 0.25. Type in 3/4 minus a half. See what the difference is. It's 0.25. So this is always adding 0.25, or I hope you understand, a quarter. It's the same, so yes. What's up with this one? We go from 1 to 5/6. 5/6 minus 1. Oh, here's a little key you forgot about. Math, enter, enter. You're losing a 1/6. 2/3 minus 5/6. Math, enter, enter. You're losing a 1/6. All right. 1/2 minus 2/3. Math, enter, enter. You're losing a 1/6. There were 3 choices on that particular example. Write the first 4 terms of the sequence defined by a sub n is 12 if n is 1. Look at that, literally. If you put a 1 there, a sub 1 is 12. And from then on, your a sub n minus 1 plus 3. And a sub n minus 1 is the previous term. I don't even want to tell you how many kids missed this one second period. But a sub 2 would be the previous term of 12 plus a 3, which is 15. A sub 3 would be the previous term of 15 plus a 3, which is 18. And a sub 4 is the previous term of 18 plus a 3, which is 21. So those are the 4 terms I was looking for. 15. Find the sum of this arithmetic sequence. There are 2 ways of doing this, and it's not hard. You can do it recursively. Recursively takes long. All right? You do 33 plus 22 plus 11 plus 0 plus a negative 11 plus a negative 22, because you have to fill in the blanks, kids. Plus a negative 33 plus a negative 44 plus a negative 55 plus a negative 66 plus a negative 77. Good thing I don't have asthma. Plus a negative 88 plus a negative 99. Now I can breathe, and you just type that in a calculator. That's what you do. Now, that being said, 1 in 3 of you will miss that when you use that technique, because you will make a typo, and you know you will. But you may not understand the other idea. Because this is arithmetic, I can actually figure out how many terms there are. And I'm going to teach this the way I used to teach this when I was last year. I can actually write a rule. The rule is that the nth term is the first term 33 plus n minus 1 times the difference of negative 11. All right, that's the rule. Now, how many are there? Like, that's what I want to know. I want to know how many there are. How many terms are there? So I know that the last term is negative 99. It must be 33 plus negative 11n plus 11. Now 33 and 11 makes 44. I feel like it makes 44. Negative 99 minus 44 is negative 143. Sorry, I had a brain fart. Well, that tells me that it has 13. There's 13 terms. Now, why? Why did I do all that? Well, because I can. And if I don't write things down, it's pretty quick. The reason I did that was because I wanted the sum of n terms. I wanted the sum, and it is n over 2 times first plus last. So that is first plus last. So it turns out there's 13 terms, 13 over 2. The first term is 33. The last term is negative 99. And I can just type that in a TI-84. I can go to math, num, n over d, 13 over 2, parentheses. If I don't know what 33 plus a negative 99 is, I don't need to know. I don't need to know that it's negative 66. I don't need to know that. Negative 429. It's test day. Nobody's asking you to do complicated math in your head on test day. Which is the same thing you would have got up there. All right. Oh, these were a disaster. I think just bad. So in a theater, there are 48 chairs in the first row. Each row has 4 more chairs than the previous row, and there are 22 rows. How many chairs are there in the theater? You know, I don't know that anybody in second period had a whole lot of work ethic to do this old school. You got 48, then you got 52, then you got 56, 60, and think about the rows you're on. This was first row, second row, third row, fourth row. There's 22 rows, by the way. 64, 68, 72, 76, 80, 5, 6, 7, 8, 9. I'll be here all day, won't I? Will you get the answer? Yes. You could just kind of go through here and you could do the sum. But you're going to have to figure out this pattern until you get to 22nd row. Or you could just use formulas. You want to use the sum of n things rule because this is arithmetic that's happening. We're always adding 4. And it is the number of items that you have over 2 times first plus last. You know a little bit about this. You know there's 22 rows. You're finding the sum of 22 rows. It is 22 over 2. You know the first row has 48 chairs, but the last, well, that's where formulas come into play. Now, you have a formula, you have access to your reference sheet, and I think this is on there. A sub n is a sub 1 plus n minus 1 times d. So if I want the 22nd row, n is 22. The first row had 48. We're on 22 row. The difference was 4. Push some buttons. 48 plus 20. I'm just going to pretend I have no idea what 22 minus 1 is, because I'm sure one of you doesn't. There's 132 chairs in the last row. That goes there. And then I crank it out. Let's see, math, no, n over d, 22 over 2. And I'm just pretending you can't do anything. 1,980 chairs. All right, 17 says solve by graphing. I'm going to do this old school by hand. Right 1, up 3. Slope, rise 1, run 2. Both ways, because you're trying to draw a V. V's go both ways. Now, I'd only graded second period as of writing this, and there was 1 or 2 students who tried to do this by graphing, and they had a rough idea what was going on. But their lines weren't straight. You can't solve by graphing if you don't use a lot of points and draw straight lines. You got to have straight lines. This guy has absolute value of x. That's a mom function. Rises 1, runs 1, runs 1. We have a problem here. I'm going to have to infer, aren't I? Oh well. Anyways, where was I? That's what I'm seeing. Now there is an intersection over here. And when you take your test, you'll have something appropriate to your grid. But there is an x value. That's where x is 5. There's a solution. And as far as interpreting what's going on here, it looks like it takes 2 blocks to gain a unit. It does. It takes 2 blocks to gain a unit. So if I was at -5, I would be 1 unit away from this grid. The other one's at -7. What I was doing there, for those of you that are curious, I noticed that here's a difference of 3 and here's a difference of 2, which means that this should be a difference of 1. It's taking 2, you have to run left 2 places to go up, to catch up. So it should be back here at -7. And speaking of things, I can check myself, can't I? And I can even make sure that I actually have my graph right. I can go to my TI-84. I can go to Y1. I can type the equation in. I can put the left-hand side in Y1. I can put the right-hand side in Y2. And I can do a zoom 6. It's what I can do. I was a little curious about that one. Let's check and see if Milbrath's brain's working right. Second trace 5 for intersect. Take the cursor. You get Z cursor close. And once it's close, you press enter 1, 2, 3 times. And I was right. It's at -7. You can literally hit second table and grab points. Let me get this table set back up. You can literally hit second table, if I'll ever get it set up right. There we go. And you can grab points. You can grab some nice points that you could actually plot. You don't have to know how to graph. You just have to know how to work this on a test. Figure it out, kids. Use a graph to solve for absolute values of x minus 2 minus 1 is greater than 3x. Nobody in second period graphed that right. Like nobody. It rises 3 and runs 1. Nobody in second period graphed 3x. I'm sorry I'm dishing on y'all second period, but y'all have to get better. That is literally 3x. Starts at 0, rises 3, runs 1. All right, here we have a down 1. We have a right 2. And there's our slope for the v. So right 2, fall 1. Slope is to rise 4 and run 1. Rise 4 and run 1. Oh, I was supposed to go right 2, wasn't I? Sorry. I'm really tired. Now, the greater than symbol. This is literally asking where is the v above the line, and that's happening here. It quits happening over here because here the line is actually above the v. It happens here. It happens way on the left at -infinity, and it stops happening at 1. So -infinity to 1. There's that one. 19 will solve systems algebraically. I am going to do the elimination technique on this one. I think one kid in second period got this one right. That's pretty bad. I'm going to take that and multiply it by a -2. I mean, if you're struggling to do this, you're even going to struggle next year in bridge math, and nobody's supposed to struggle in bridge math. So I took the bottom equation and multiplied by -2 because I was thinking about outcomes. That's why I did it. I was thinking about outcomes. The outcome is there's no x's, there's 8 y's when I add them together, and 12 and -32 sums to be a -20. Okay, so we got a fraction. That's okay. Y is -20 over 8, which is -10/4, which is -5/2. And when you take your test, it'll be something I designed to come out to be a nice, decent answer. Of course, this isn't that bad. It's really not. Anyways, what do I do with it now? I plug it in. And you can pick either equation you want. I mean, you have access to a calculator, so I don't understand the issue. If you don't know what -5/2 times 6 is, I hate having to remind kids they can do this, but you can go to your calculator. You can type 6 times a -5/2, and by God, it's 15. So 2x minus 15 is 12. I add 15 to 12, I get 27. I divide by 2, and there's my x value. Assuming I made no mistakes. I don't think I did. Anyways, ordered pair. Well, actually, what do I want? The ordered pair is 27/2 -5/2. And I feel like your test says 4x only. So, that one. And then there's the last one. I legit think in my entire second period class, only 2 people got number 20 right. Left into Y1, right into Y2. If the issue is you don't have a TI-84, you go talk to the librarian. Now, a lot of kids will be like, well, I didn't know that. That's because you listen to the videos on mute, bro. Or you just don't do it. Right. Figure it out, man. Figure out what you got to do to pass. Because for most of you, what you're doing is not working. It's not working. You have to change it. I do not adapt to you. You have to adapt to me because I have high standards. So you have to adapt to the person with very high standards. Anyways, Zoom 6 it. There's 2 answers. Second trace, 5 for intersect. Get close and then enter once, twice, thrice. There's an intersection. There's an x value of around -3.1652. The other one's actually a nice number. Pretty sure it's 0. Second trace, 5. Get close, enter, enter, enter. Oh, look at that. Look at that. This is scientific notation. I did this problem earlier and it actually told me x was 0. It is 0 because you are supposed to move that decimal 15 places to the left. 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 2, 6, 9. I think that's right. This is essentially 0. And it's a rounding error by the calculator. So, 0. And I am done with that. I'm glad too, because I'm tired. Plus, I still got to record a video of me doing your test.